Hey students, this is kind of like a practice problem for the test. So we're gonna first graph, like a cubic. So I'm just kind of deciding where the zeros are here. I'm looking at this to see. I'm just moving my vertex around. Let me go up here and just zoom in so I can see all the integers. There we go. So I'm just kind of trying to put this. All right, there. So we're getting a 0 here and a 0 here that are both irrational. So then I'll just choose my other one to be like maybe 7/2. So I'll just change that to 7, and it should move this thing over to here. All right. So this is the G is the cubic that we're interested in. So this is the expanded form of it. So this is what I'm going to write down. Move this over here and write that down. So graph G of x, I'll call it f of x in this case. F of x is this thing here. 2x to the third minus x squared minus 30x minus 7. Alright. And then when I'm doing a rational function, I'll just do graph r of x is that same function, so 2x cubed minus x squared minus 30x minus 7, and then let's get this back here. Get rid of that and that, and then I'm going to make a rational function that just this thing's definition is g over a couple of zeros. So let's put g there so we know where it crosses, and then I can make a vertical asymptote be at -2 into 2. So if I do that, I get that. Okay, so now this r of x is the thing I'm going to deal with. Okay, so all of that over, it's supposed to be 7, over an x squared minus 4. Okay, so we'll do that problem as well, but we're going to start with the cubic numerator, right? That's like problem 1. So we're interested in mid behavior and then end behavior. This isn't too big of a deal here. We know the right tail does that because this is positive, and the opposite tail does the other tail does the opposite. There's not much analysis to do there. The only things in mid behavior that we care about are zeros and the y-int, so just where it hits the axes. So the y-int's easy. 0, -7. Now this thing, we have some numbers we need to check, so we're going to just rational root that. So I'm going to put this in y1. Alright, -30x minus 7. And then I'm going to check numbers with either 1 or 7 in the numerator and then 1 or 2 in the denominator. So I'll try 1, -1, 7, -7. None of those worked, so now I'll try all of them with a denominator of 2. That last one worked. So one of my zeros is -7/2, which is -3.5. So I only was able to get one rational 0. So to get the other 2, I need to find So I know that I'm factoring this into x minus, okay, actually x plus 7/2 in this case. But now I have some quadratic that I need to get. So I'm going to get that from doing synthetic division on this. So I'm sending in the number I just found, negative 7/2. So 2, negative 7, negative 8, 28, negative 2, 7, 0. So it's 2x squared minus 8x minus 2. So I'm going to factor 2 out of here and distribute it into there. So I get 2x plus 7, x squared minus 4x minus 1. This is my quadratic. So I am going to set that to 0. And then if I did that, I would get x is 4 plus or minus the square root of 16 minus 4 times 1 times negative 1 all over 2. So this is really a 20 under here. So that's 4 root 5. Or that's 2 root 5, right? It'd be 4 times 5. So I'm going to get 2 plus or minus root 5. So I'm getting 2 other zeros here. 4.24 and negative 0.24. Okay, so there are 2 other zeros there too. I'm going to say 4.20 and negative. I'll do 4.24 and then negative 0.240. So I have those 3 zeros. So there's the analysis. Now I can make a table. I'm going to put these 4 numbers in here. The smallest is negative 3.5. Next smallest is negative 0.24. Then the one intercept. And then the other 0. And then I just put in some more numbers. Those are close enough together. There. Those are these 2 numbers down here. I got negative 2. I want to check to see if I got 0 right. 2 and 5. Negative 4 gives me negative 31. And then 33. And then that 0, and then the y int. 2 gave me negative 55. And then 5 gave me 68. So my smallest number is this, and my biggest number is this. So I'm gonna go negative. I'll go negative 100 to 100. That ought to do it. And then I'll go maybe negative 6 to 6. There. Everything should fit nicely in there. Okay. That's like negative 20. I'll go by tens rather than do that. So bam, 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 bam. Each of these is like 10. Okay. We just plot these. -4, -31. So if that's -30, pretty close to that. 3.50, -2, 33, so that's a little above that. Well, -1/4 basically, 0. And 0, -7 is like right there. 2, -55 down here. 4.25, 0. 568. Okay, so it looks to me like it does this. Let's see. Get a hundo. Pretty much, yeah. Cool. So that's all you needed to do on that. So this problem, we're kind of doing the same thing. Be a good idea to factor this. Now we already factored that thing. We said it was 2x plus 7, I think is what we said. 2x plus 7 and then x squared minus 4x minus 1. And this factors into x plus 2 and x minus 2. Okay. So there's no holes or anything there. Alright, let's just do mid behavior and end behavior. Okay. Now, mid behavior thing, we want holes, we want vertical asymptotes, we want zeros, and we do want that y-int. Y-int is when you plug 0 in, and then you're left with -7 over -4, so that would be 7/4. What is that? That's 1 3/4, so 0, 1.75. We already, so there's no holes. And we know the zeros, it's the same zeros we got here. So these three things are the answer to that. -3.5, 4.24, and -0.24. Right? Yeah. Vertical asymptotes are, these are giving them to us. Now for end behavior, what we do is we divide this by these, one at a time. 2, -1, -30, -7. We put in 2 first. Doesn't matter which one I choose. 2, 4, 3, 6, -24, -48. Who cares? Now we just do, we now send in the -2 into this. 2, -4, -1, 2, and who cares? This is it. So the end behavior is y equals 2x minus 1. Now we are ready. Table of values. It's a good idea to put your vertical asymptotes in the middle, sort of. Just sort of spread them out a little bit, and then what I usually want to do is cluster up around there. Okay. And now I want to put in some numbers in here, assuming I have them occurring, and I indeed do. Like right in the middle of them would be 0. And I know that that gives me 1.75. And these were both vertical asymptotes. What else is happening? Is there any other numbers in there? Yes. We have a 0 at negative 0.24. That's it for within there. So why don't we also choose negative 1 and 1. And then negative 3.5 shows up. So let's do negative 3 and negative 3.5. Then this 4.24 shows up. So I'm going to do 3, 4, 4.24, and then an end behavior. A little end behavior would be a good idea. And then maybe negative 4 and negative 5. That should give us a pretty good table. So we have our 4 points. 1, 2, 3, 4 are in there. We have our vertical asymptotes in there. And that was all we had. So I'm going to figure out what these other numbers are. And it's convenient that that's in there. And I want to divide it by x squared minus 4. Negative 5, negative 4, negative 3.5, hopefully gives us 0, negative 3, negative 2.5, negative 2 should give us an error, negative 1.5, negative 1, negative 0.24. I know that's going to work, so that's this number down here. Clearly it worked. So I'm skipping that. If I put 0 in, I should get 175. Okay. And then 1.5. Negative 6.3, I'm going to call it. Negative 2.6. Negative 3 gives me 4. Negative 2.5 gives me 13.5, 13.6. Then I get the error. Then negative 1.5 gives me negative 16.6. Negative 1 gave, negative 1 gave me negative 6.7. Then I got a 0. Then I'm at, so 0 gave me the right thing. 1 gives me 12. And 1.5 gives me 27.1. I guess I'll go up here again. So we left off at 1.5, 2, 2.5, and then 3, 4. Don't care, and then 5, 6. 2.5 gave us negative 25.3. 3 gives us negative 10.4. 4 gives us negative 1.25. 5 gave us 3.2. And 6 gives us 6.5. Cool. Completed table. Now we can graph it. What is the smallest number in here? -6 so far, -16 so far, at -25.3. Yeah. That's our smallest. Now, biggest. 4 is 13, 27. Those are our sort of setting up our y-axis. So I'm going to go -30 to 30. And over here, I'll go -6 to 6. I'll already have these set up for you. And then everything will fit nicely in there. So that's 5, 15, 25. Okay, now we just, first things first, put all the asymptotes in there are 3. One is at -2, other is at 2. Now we have to put this one in there. Y equals 2x minus 1. So -1, alright, let's put 4 in. If we put 4 in, we get 8 minus 1 is 7. If we put 0 in, we get -1. If we put -4 in, we get -9. So it's doing something like this. Okay, cool. Now we plot. -5, -6.3. -4, -2.6. -3.5, 0. -3, 4. -2.5, 13. 6. Alright, so it's just simply doing this over here. Now on the other side, we have -16.6 when we're at -1.5. And at -1, we're at -6.7. Then at -1/4, we cross. 0, we're at 1.75. At 1, we're at 12. 1.5, we're at 27.1. So it's pretty clear what happened there. Then 2, an asymptote at 2.5, we're at -25.3. At 3, we're at -10.4. At 4, we're at -1.25. And then we cross at 1/4. And then at 5, we're at 3.2. At 6, we're at 6.5. We're doing this. That's what it should look like. So -66, 1. And -30. 30. 10, or 5, I guess. Put that line in there just to make sure it looks right. 2x minus 1. Okay, if we wanted to see more of the end behavior, we could just maybe go -12 to 12. That's why you usually kind of do want to go out a bit so you could see that asymptotic behavior, but whatever. I'm happy with my drawing. You could encounter a question maybe that says when is, because remember 4.6 was covered and it will be on here, so when is maybe the f of x negative? So when is it non-positive? Okay, well, we can just look at our graph of it, right? So we're asking when is it below, on or below the x-axis? Here and here. So this was that. This was the -3.5, right? So left of -3.5 and including at -3.5, we hit the x-axis. So I'm going to say -infinity to 3.5, and then we start at the 0 here, which is like the -0.24, and we go on to the other 0. That is just from all the analysis we did, we can determine that. So suppose we asked when is the rational function we found positive, strictly positive. Well, we can just look at our analysis that we did, and okay, after the first 0 and up until the vertical asymptote, and we don't include the 0 because it's strictly greater than. So the first 0 was the -3.5 again. So -3.5, and we go up until this asymptote -2. Do not ever include the asymptote. And then it's positive. And then, are we asking when it's positive? Yeah, so I'm being an idiot. We want to know when it's positive. So after the 0 and before the 0. So I had that right. After the 0 but before the asymptote. Then this part we skip. And then when we hit that 0, so again, from the next 0 onto the asymptote, again that happens. Okay, so that 0 is at -0.24. -0.24. And we go on until the next asymptote. And then it's negative again until the next 0. So that was the 4.25. 4.24, and then we go on and on and on. Okay, so remember that kind of question could be asked. Yeah, that's pretty much what you need. So good luck on that. You're going to do fine.